Hello students, Sairam. Today we are going to start a new chapter, chapter number 9, Rational Numbers. First is introduction. In that we will revise natural numbers, whole numbers and integers. And then we will understand need for rational numbers. Then what are rational numbers? Is every rational number a natural number? And then equivalent rational numbers. And based on equivalent rational numbers, we will do two questions of exercise 9.1. So let us start. First is natural numbers. You know about it. Numbers starting from 1 are called natural numbers. Like here, this is the example. 1 to infinite are natural numbers. And the smallest natural number is 1. This is the smallest natural number. Then whole numbers. Numbers starting from 0 are whole numbers. Like here 0 and then these are all natural numbers to infinite. These all are whole numbers. Now here you see 1 to 7 and then infinite. These all are natural numbers. Whole numbers are 0 plus all natural numbers. If you include 0 with all these natural numbers, then they are called as whole numbers. So whole numbers are 0 plus natural numbers. And the smallest whole number is 0. And smallest natural number is 1. And then integers. Integers also you know. Integers are positive numbers plus negative numbers plus 0. That means all the positive numbers you can see here, these all are positive numbers till infinite, all the negative numbers till infinite and 0. They are all together called as integers. Then fractions. Fractions are the numbers which are written in the form of numerator upon denominator, where numerator is either 0 or positive integer and denominator a positive integer. That means both numerator and denominator should be a positive integer. Then only it will be called as a fraction. Need for rational numbers. Now we will understand why there was a need for rational numbers. Earlier we have seen how integers could be used to denote opposite situations involving numbers. For example, if the distance of 3 kilometers to the right of a place was denoted by 3, then the distance of 5 kilometers to the left of the same place could be denoted by -5. This we have learned before. If a profit, there is another example, if a profit of rupees 150 was represented by 150, that means positive 150, then a loss of rupees 100 is represented by -100. We can represent a distance of 750 meter above sea level as 3/4 kilometer. Can we represent 3/4 kilometer below sea level by -3/4? As -3/4 is neither an integer nor a fractional number. It is also not a fraction because there is a negative sign. So we need to extend our number system to include such numbers which are called rational numbers. So rational word is derived from the word ratio, which actually means a comparison of two or more values or integer numbers and is known as a fraction. In simple words, it is the ratio of two integers. So we can say a rational number is the ratio of two integers. Then now what are rational numbers? Rational numbers are the numbers which can be written in the form of P upon Q, where P and Q are integers and Q is not equal to 0. So you can see these are the example of rational numbers. 2/3. You can see both the numbers, they are integers. 2 is also an integer, 3 is also an integer, and q means the denominator is not equal to 0. Here also you see minus 4 is also an integer, 5 is an integer, and this is not equal to, denominator is not equal to 0. 8 can be written as 8 upon 1. So denominator is again not equal to 0 and 8 is an integer. So these all are the examples of rational numbers. Now you must be thinking, then what is the difference between fraction and rational numbers? Fractions are written in the form of a upon b, where a and b are whole numbers and b is not equal to 0. Whereas rational numbers are written in the form of p upon q, where p and q are integers and q is not equal to 0. That means here you can see in fraction a and b, that means the numerator and denominator should be always whole numbers. You cannot take negative number here. Whereas here you can see numerator and denominator are integers. Integers means you can take negative number also. Here you cannot take. So this is the difference. Now second difference, all fractional numbers are rational. So any fraction can also be called as a rational number. But all rational numbers are not fractions. Now let us take some example. 1 upon 3, 1 upon 4, 1 upon 8, etc. These all are fractions. And they are also called rational numbers. Here minus 11 upon 2, 3 upon minus 4, etc. These all are the example of rational numbers. They are not fractions because you can see here there is a negative number in the numerator. Here also. In the denominator there is a negative number. So it cannot be a fraction. These are called as rational numbers. Now see this figure, you will understand here all natural numbers are whole numbers. You can see here this is natural number. So all natural numbers are also whole numbers. All whole numbers are integers. You can see here whole numbers are also integers. All whole numbers are integers. All integers are rational numbers. So which means that rational numbers include integers, whole numbers, natural numbers as well as fractions. Now next is every rational number a natural number? Every natural number is a rational number, but a rational number need not be a natural number. So let us understand with the help of example. Now here you can see this is a natural number 1. 1 can be written as 1 upon 1. 2 can be written as 2 upon 1. 3 can be written as 3 upon 1. We can write 1 in the denominator and so on. So can we call them as a rational number? Yes, natural number can be a rational number. Now here you see clearly 3 upon 2, 2 upon 5, 1 upon 7, 15 upon 20, etc. These are the example of rational numbers. But they are not natural numbers. Hence every natural number is a rational number, but a rational number need not be a natural number. Now let us take some example. Is 0 a rational number? We can write 0 as 0 upon 1. So here you can see it is written in the form of p upon q, numerator upon denominator. Both are integers and the denominator is not equal to 0. So 0 is a rational number. Now next example, is minus 31 a rational number? Minus 31 can be written as, you can write like this, minus 31 upon 1. Since we have integers on numerator as well as denominator, you can see this is an integer, this is also an integer. And this one denominator is not equal to 0. So it is a rational, minus 31 is a rational number. Let us take one more example. Is minus 4 upon 9 a rational number? Since minus 4 and 9, you can see both of them are integers. And they are on numerator and denominator and they are integers. And the denominator is not equal to 0. So it is also a rational number. Now next we will understand equivalent rational numbers. Equivalent rational numbers are same as equivalent fractions. We have learned in the lesson number 2 fractions what are equivalent fractions. So similarly equivalent rational numbers are also same like equivalent fractions. Here you see this example. This is the whole pizza is divided into two parts. So this is half of it, 1 upon 2. And here it is divided into 4 parts, and then also you can see here it is 2. These are the two parts of the whole pizza, 2 upon 4. And if it is divided into 4 parts, then it will become 4 upon 8. And you can see all the 3 are equal, they are equivalent. So we can say 1 upon 2 is equal to 2 upon 4, and 2 upon 4 is equal to 4 upon 8. So here 1 upon 2 is equal to 2 upon 4, and that is equal to 4 upon 8. So these are equivalent rational numbers. Similarly, we can use negative numbers also. Here you can see minus 1 upon 2 is equal to minus 2 upon 4, and that is equal to minus 4 upon 8. Now we will learn to find out equivalent rational numbers. Now here this is an example, minus 2 upon 3 for rational number. This is a rational number, and we will find out equivalent rational number to this rational number. You can see here this is done here, minus 2 upon 3. When you multiply numerator and denominator by 2, you will get here minus 4 upon 6. Same way here, both numerator and denominator is multiplied by 3. So minus 2 into 3 is minus 6, 3 into 3 is 9. So this number, this rational number is equal to this rational number. So we can say minus 2 upon 3 is equivalent to minus 6 upon 9. Same way, when we are multiplying both numerator and denominator by 4, we will get minus 8 upon 12, which is again equivalent to minus 2 upon 3. And when you are multiplying by 5, here both numerator and denominator will get minus 10 upon 15. So they are equivalent. Same way, if you divide this minus 10 upon 15, if you divide it by 5, you will get minus 2 upon 3. If you divide this rational number by 4, you will get minus 2 upon 3, and they are equivalent. Which means by multiplying or dividing the numerator and denominator by the same non-zero integer, we can obtain another rational number equivalent to the given rational number. So you can multiply also, or you can divide also, but you have to divide or multiply by the same number, then only you will get a rational number which is equivalent to another rational number. Now here we will do one question. Question number 3. We'll start from question number 3 of exercise 9.1. Give 4 rational numbers equivalent to minus 2 upon 7. The way we have done just now, we will do this also. Equivalent rational numbers are now here. What we'll do, we'll write down the rational number which is given in the question. And here you can see the numerator and denominator both are multiplied by 2. So you will get minus 4 upon 14. Here when numerator and denominator both are multiplied by 3, you will get minus 6 upon 21. Same way here you will get, when you are multiplying both by 4, numerator and denominator by 4, you will get minus 8 upon 28, and they are equivalent to this rational number. Then minus 2 upon 7 will be multiplied, both numerator and denominator is multiplied by 5. So you will get minus 10 upon 35. So 4 equivalent rational numbers are minus 4 upon 14, minus 6 upon 21, minus 8 upon 28, and minus 10 upon 35. So this way you have to find out equivalent rational numbers. Now one more question, question number 2, that is 5 upon minus 3. So 5 upon minus 3 can also be written as minus 5 upon 3. We will write the negative sign, we'll bring it here in the numerator. And then same method, we'll multiply numerator and denominator by 2. You can see here it is multiplied, and you will get minus 10 upon 6. Second one, both numerator and denominator is multiplied by 3. So you'll get minus 15 upon 9. Here you can see both numerator and denominator is multiplied by 4. So you'll get minus 20 upon 12. and the last one is minus 25 upon 15. So these all are the equivalent fractions. So this way you can find out many. Here they have asked for 4 rational numbers, so we have written 4 rational numbers. If you want, you can find many rational numbers. Now children, this is your homework for today. Question number 2 of exercise 9.1. Write 4 more rational numbers in each of the following patterns. Here you can see 4 rational numbers are given. You have to write 4 more rational numbers. You have to see the pattern. On that basis you have to write. You have to find out other 4 rational numbers. Here 3 are given, so you have to find another 4 rational numbers. Now next question, question number 3. 2 parts we have done today. This is the third part. You have to give 4 rational numbers equivalent to 4 upon 9. So this question you will do it in your maths notebook. That's all for today. Thank you.